Okay, good morning grade 11s. This is basically a follow-up video on the identities that we've been doing. It's the last little section and it's quite easy as long as you've understood what we've been doing with identities. So basically they're going to ask you for which values is the identity undefined. So when something is undefined, we're looking for divide by 0 and square root of a negative because it's when it doesn't exist. Okay, so they'll probably give you an expression and then ask you to find specific values or find the general solution. So for dividing by 0, as you can see here, this is the denominator. So this whole thing, if it is 0, this does not exist. Okay, even within this fraction, there's another fraction, 1 over cos x. So if cos x is 0, that does not exist. Okay, but there's a few things that you need to look out for. The first thing is tan x. If you see tan x, okay, first of all, what is tan? If you look at your identities, what is tan x usually? Tan x is the same as sin x over cos x. So if you have tan x in an expression, you need to be careful because technically cos x is at the bottom. It's invisible, but it's at the bottom. So you need to find out when cos x is 0. So whenever you see a tan x, you're always going to have 90 plus k1 plus or minus k180 as one of the solutions because it's divisible by cos x. So we are covering that base just in case that cos x comes up. And the reason it's 90 plus minus k180 is because if you look at a cos graph, we're looking for where it's 0. Do you agree with me that with this shape over here it's 0. Here, it's 0, and it's probably going to be 0 around here somewhere again, and at minus 90. So from 90, if you keep plussing 180, from 90 to 180 is 90, from 180 to 270 is another 90. So from 90 to 270 will be 180. So every 180 degrees, you get another 0. So cos x is always 0 at 90 plus minus k 180. It's one of those special angles. Okay, so whenever you see tan x in a question, immediately write that down as a solution. You don't even need to understand it. You just need to know x 90 plus minus k 180 is the solution. Okay, so if I look at this one, I already see a tan x. So before I even get started, for my first solution, I'm just going to say 90 plus minus k 180. Okay, another thing that I want you to look out for and understand before we get started is sine and cos are never larger than 1 unless there's a number in front of it, so like 3 sine x, then you know your amplitude will change to 3. But if you're looking at your ordinary basic graphs, it never gets larger than 1 and it never gets smaller than negative 1. It's stuck here between these two numbers. The same thing with cos, never gets larger than 1 and never gets smaller than negative 1. Okay, and then just as a matter of interest, tan x, I've drawn a little graph here for tan x. You can see that at 0, tan is 0, 180 tan is 0. So from 0, every 180 degrees, tan will be 0. Okay, all right, but let's get started. So the first thing we're going to do is tan x. We already know that because tan is sine over cos, our first solution is going to be x equals 90 plus minus k 180. Okay, and if you think about it, that solution also covers this section, right? Because this is 1 over cos x. We don't want cos to be 0, the same as we didn't want cos to be 0 there. So this is the solution for this and this. We don't even have to do anything further for this part. Okay, but then we still need to look at the fact that this whole thing is a denominator. So for that one, 1 plus 1 over cos x equals 0. We need to solve for this. So now we're going to take the 1 over. So it becomes negative 1. You just invert it. You get cos equals negative 1. Are you with me? Okay, so again, you could actually just read this off your graph if you wanted to. If you look at your cos graph, here's negative 1, right, at 180. So your next negative 1 is going to be in 360 degrees. But if you want to, we can do it the old school method just to make sure you understand. Your reference angle would be what? If I say shift cos of positive 1, shift cos of positive 1 is just going to be, it's just going to be 0. Again, you can see that off your graph. Here at 1, it is 0. Okay, so we've got 0. So then you need to decide which quadrant we're in. We're looking where it's negative. So it's here and here. This is 180 minus x. This is 180 plus x. So x equals 180 minus 0 plus minus k 360. So therefore x equals 180 plus k 360. Do you see if we go and do quadrant 3, we're going to get the same thing. 180 plus 0 is just 180. So as I said before, this was something that was very simple to read off of your graph, because you were looking for where cos is negative 1. Cos is negative 1 at 180, and it repeats itself every 360 degrees. Okay, so that's your solution for this. So these are your two options. They may ask you for specific solutions. You guys know how to do that. If they say they want the solutions between, let's say between negative 360 and positive 360, you go and plug in numbers here and make sure that that falls between those two numbers. Okay, cool. So just to review, if you see a tan x, you know that 90 plus 1k180 is going to be one of the solutions. Okay, why? Because tan is made of sine over cos. So you are looking for where this thing is 0, where that thing is 0. That thing is 0 when it's 90 plus minus k180. So you can just memorize that. That's why this solution covered this part as well, because you were also dividing by cos x over there. And then again, you have to look out for when you're dividing by 0 or when you're taking the square root of a negative. We didn't have to worry about the square root situation because there was no square root here. So we left that alone. Okay, so now let's do another example and then you guys can try some on your own. Alright, okay, so now I just started. Immediately my brain saw I have a tan x. So I know immediately one of my solutions, just write it down immediately. X equals 90 plus minus k180. Why? Because tan is sine over cos. This is the solution for when cos is 0. You can go and you can double check that. Okay, now we've got two other things taking place here. Tan x is a denominator. So we're going to have to find a solution for when tan x is 0. Remember, this is the solution for when cos x is 0, because tan is sine over cos. But tan is also at the bottom of something, so we need to find where tan is 0. As well as the fact that we've got a square root. We don't want this to be negative. So let's go and handle the tan. So we need to find out when tan x is 0. Whenever you have these main points, just go and check on your graph. It makes your life easier. When is tan 0? Tan is 0 at 0, 180, and then probably around here somewhere when it has another one of these. So you can see these are 180 degrees apart. So tan x is 0 when x equals 0 plus minus k 180. Right? Makes sense. It's at 0 and it repeats itself every 180 degrees. So there, that takes care of it for us. If you want to do your other method, you can go and check shift tan 0 is just 0. And yeah, repeats itself every 180 degrees because it's tan. Alright, now the last part of the solution is when this thing is negative, this whole thing in the bracket. We don't like it to be negative because then it's a square root of a negative, which doesn't exist. So 1 minus sine squared x is smaller than 0. Smaller than 0 means negative. There's two ways to go about this. The first thing is, if I go and do you remember that 1 minus sine squared x is just cos squared x, right? You could do two things. So do the solution first. Cos squared x is smaller than 0, okay? Which doesn't happen, that never happens, okay? Or, okay, you solve it this way. So 1 minus sine squared x smaller than 0, take the 1 over, so it's smaller than negative 1. Divide everything by negative 1, so sine squared x is larger than 1. If you wanted to square root both sides, you get sine x larger than 1. Is sine x ever larger than 1 if you look at your graph? No. Remember I told you? It sticks between these two. Sine x will never be bigger than 1 or smaller than negative 1. Same thing over here. So basically you could go two ways with this, but just makes sense like that. Okay. Alright, so that's just what you need to look out for when they want to know about undefined. But if you have any questions, again, you guys can WhatsApp me. Very simple. Basically finding your general solutions unless they ask for specific solutions. But yeah, I think you guys have got this.